Okay, so hi guys. I wanted to make this really quick video because I don't think I went over limits um of trigonometric functions, especially this rule here that we have to kind of, we have to remember this rule for calculus, because it does come up, well, in Cal 1 it does come up on the final, and it does come up on AP calculus as well. If you're in AP calculus, so we have the limit as x approaches 0 of sine of 3x over 5x. Now, obviously, doing direct substitution won't work, right? Because, we get a sine of 3 times 0 over 5 times 0, right? And this cannot work, right? I mean, it'll be undefined, or it'll be like a 0 over 0 kind of thing. And, so what else do we do here? Well, there's a rule, right? And as you all know, whenever I make videos, I always like to point out the rule that I use for certain problems. So the rule is that if I have the limit as x approaches some number c of sine of, let's say, ax over bx, then this is equal to, it's going to be a over b times the limit as x approaches some number c of, or actually it'll be 0 actually if this is considered, like that, of sine of x over x. And I can't really show you guys how, because I would try to see, using a table, how with the limit as x approaches 0, what the limit is of sine of x over x. But I'm just going to give it to you guys just for reference. So actually the rule is that the limit as x approaches 0 of sine of x over x is just going to be 1. And then I believe, hold on one second. I think, well, for this example, that's what I'm going to do here. And so what we end up getting is, we obviously get 0 over 0, right? And we can't have that. But if I'm saying the limit, and I'm going to rewrite this down, so give me 1 second, guys. Okay, so what I can do is the following. If I have this, I can use this rule to find that limit. So we know that this will be equal to 3/5 times the limit as x approaches 0 of sine of x over x. And we know that this is true because of that theorem, right? That's kind of how it works, and this is the theorem that, this right here is the rule that we use for this. And so we already know that from, if you've already done the graphing part for this, you already kind of know, or the table, you already know that this is true, that basically the limit as x approaches 0 of sine of x over x equals 1. So this will be equal to, and we're gonna have, so first we have the 3/5, right? So 3/5, and then times, and it'll be, and this part here, like I said, the limit as x approaches 0 of sine of x over x is equal to 1. So we're just gonna put a times 1 there, right, for this part. So then this will be 3/5 times 1, and it'll just be 3 over 5. So that is kind of the rule here that we have to remember. Just know that whenever there's like a number here and a number here, that's basically the limit as x approaches 0 of this. So that's kind of the way that I remembered it when I was in Cal 1. I'm going to do another example, guys, so that, we kind of, because there's another rule with this, and I'm going to show you guys that other rule. So give me 1 second. Okay, guys, so I found it. So we're gonna do this problem. I remember now how to do this. We have here the limit as x approaches 0 of cosine of 2x minus 1 all over 3x. And obviously, like I said, if we do direct substitution, by direct substitution, we get cosine of 2 times 0, so times 0, and then minus 1 over 3 times 0. And obviously that's not going to work because then we end up with 1 minus 1 over 0 because of cosine of 0 is 1. So this can't work, right? So we need to do other things, right? And like I said, I'm going to write down the rule that I saw. So the rule is this, and if I have the limit as x approaches some numbers, or let's say x approaches 0, let's say I say the following: cosine of a x over b x, then this means that I'm gonna have the following: a over b times the limit as x approaches 0 of the cosine of x over x. And we know that the limit, also another rule is that the limit as x approaches 0 of cosine of x over x is really going to be equal to 0, I believe. If I'm correct, yes. Or I'm sorry, cosine of x minus 1, excuse me, over x is equal to, if I have minus 1 here, sorry guys, hold on, minus 1 over bx is equal to the limit as x is equal to a over b. Sorry, give me 1 second, guys. I'm gonna write it down. All right, sorry about that, guys. So this is the rule, right? And this is the rule we're gonna use for number 2, right? So we have cosine of 2x and then minus 1, and then it says over 3x. So what I'm gonna do is I'm gonna say the limit as x approaches 0 of cosine of 2x, so 2x, and then minus 1 over, it was 3x, right? So 3x. And this is actually going to be equal to 2 over 3 times the limit as x approaches 0 of cosine of x minus 1 all over x. And so, like I said, this becomes 2/3. And then, like I said, over here, this is really what this is. So it's times 0 because the limit as x approaches 0 of cosine of x minus 1 all over x is 0. So it's going to be 2 over 3 times 0, which is just 0. So thus, the limit as x approaches 0 of cosine of 2x minus 1 all over 3x is equal to 0. So this is my answer for this one, right? And so that is the, and actually I forgot to put, I like to put it in the full form here. It's equal to 3/5. So this is the answer for this one, right? So that is how you do these two problems, guys. Sorry if it was a little bit, took me a while because I had to look up the rule for the second one. But with that being said, guys, thank you so much for watching, and also please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.